choice of an underground mining method depends on a range of factors, and these include the size and shape of the deposit, the orientation or slope of the deposit, the depth of the deposit, geological structures, characteristic of the ore and the surrounding rocks, and issues with gas and water. In combination, these factors allow us to determine an appropriate arrangement and sequence for a mining operation. But before going on to look to see how they combine to mine specific geological ore bodies, let's have a look and familiarise ourselves at the different basic elements of an underground mine and their basic purpose. Before an underground deposit can be mined, it must be accessed. Access to an underground ore body is achieved through a combination of shafts, which are vertical tunnels, drifts and drives, which are horizontal tunnels, and declines and ramps, which are inclined tunnels. Access provides for getting people and equipment to the ore body, getting mined ore and waste out of the mine, ventilation and emergency egress, and getting waste and tailings in to backfill the mine. In general, the access arrangements for people, equipment, ore and air are separated. Typically, declines are good for the movement of equipment and people, whilst shafts are efficient for the movement of ore. This figure shows a 3D model of a mine for a vertical ore body embodying the basic elements. As was alluded to in topic 1, one of the disadvantages of underground mining is the need to manage the overlying rock as the ore is extracted. Any portion of the ore body that's left behind for operational reasons during mining is lost to production. Because access structures are mostly permanent, it makes sense to locate those outside the ore body in the worthless rock beside. This is also good for safety reasons in the event that there might happen to be an unexpected collapse in the ore body during mining. The excavation of access structures is generally undertaken in what is referred to as a development phase, and it's described as dead work. Once the ore body has been accessed, it is removed block by block by either stoping or by caving. A stope is the open space left behind when ore is removed. Implicit in the idea of stope mining is the idea that the roof does not collapse after a stope has been created. This is in contrast to caving, where it is intended that the stope is temporary only, and that the roof of the excavation will systematically collapse as part of the mining operation. In order to keep a stope open, something must hold up the roof when the ore is removed. There are two basic ways of achieving this. Open stoping is where pillars of ore between the stopes are left behind. Supported stoping is where artificial supports are installed between the stopes to support the roof, allowing the pillars between the stopes to be removed. We will look at these approaches in greater detail in the next topic. Stoping and caving can be carried out using a range of different mining operations. These include digging, cutting, hammering and blasting. The choice of a particular excavation method depends upon the strength of the ore and the geological conditions. Digging is carried out using buckets on excavator type machines. Cutting is carried out using machines called road headers or continuous miners, which consist of rotating cutting heads mounted on mechanically controlled arms and fitted with tungsten carbide tipped picks. Hammering is carried out using a hydraulic or pneumatically controlled pick on the end of a mechanically controlled arm. Blasting involves the use of explosives installed in drilled holes to split or possibly throw rock from an intact rock mass. The picture shows a hole being drilled in rock. These processes result in a pile of broken ore on the mine floor referred to as muck. The process of removing that ore from the mine is referred to as mucking or mucking out. Mucking is sometimes carried out by the equipment used to create the muck. In other cases, muck is cleaned from the floor using machinery such as shovel loaders, LHD or load haul dump auto loaders, and arm loaders. The ore is then transported to a loading point using auto loaders or shuttle cars. If the ore is too coarse to be moved, it may be crushed underground first to make it transportable. Mined ore underground can be taken to the surface by rail-mounted wagons, self-powered or hauled by a rope up an inclined ramp, trucks and shuttle cars hauling up an inclined ramp, conveyors installed into inclined ramps, or by skips hauled up shafts by winches. Skips, conveyors and rail systems are semi-permanent infrastructure, and so they are not easily relocated. However, the location of mining activity changes with time. This means that ore from the muck needs to be transported underground to places where it can be loaded and carried to the surface. As we noted earlier, this can be done using shuttle cars and LHD loaders. However, if the design of the mine is really clever, it's possible to locate loading points deep at the lowest levels of the mine and to deliver ore to those through chutes using gravity. This is done using vertical or inclined chutes called ore passes, specifically constructed for that purpose. Ore passes can have conical or bell shapes and may be created in the ore body itself by drilling and blasting a conically radiating, upward flaring ring of holes, effectively creating a funnel structure. We will see examples of how these features are incorporated into efficient mining operations in the topics that follow.